Now, what are the classification of functions? So, in dealing with functions, we will be dealing with algebraic and transcendental kinds of functions. So, for algebraic functions, we have two categories. We have the rational and irrational functions. And then for the rational functions, that can be integral or fractional. So these rational functions are quotient of polynomials. So it involves polynomials. And for the irrational functions, these are extraction of the roots. So it involves square roots. And on the other hand, we have the transcendental functions, which have two categories, elementary and higher. But in this lesson, we will just be focusing on the elementary category, and we have the trigonometric inverse trigo, and then the exponential, and then the logarithmic functions. So for the utilization of learning, I have uploaded the exercise. So you just answer that one and then submit. Okay, so moving on to limits and continuity. So after we have discussed functions, we now move to limits and continuity. And the target outcome for this is for you to be able to solve for the limits of a given function. And you should be able to identify a continuous and a non-continuous function, or a point in the function where it is not continuous. So what is limit? So if you're going to consider a certain function, say f of x is equals to 3x plus 1, and we assign any values of x that is near but not equal to 2. So if we assign those values, we will assign values towards the left of 2, and say if this is 2, sorry. Okay, so if we assign values of 2, so that's to the left of 2, and this is to the right of 2. So we have 1.5, 1.899, and 1.99, which is very near to 2. And to the right, we have 2.09, 2.05, 2.16, and 2.30. So these values are approaching, sorry, I will delete this first. Okay, so these values are approaching 2 from the left, and these values are approaching 2 from the right. So if you are going to solve for each value of x, such that f of 1.5, and substitute this to 3x plus 1, so we have the f of x, or the range, as 5.5, and for 1.89, 6.67, and so on. So we can have these values as our ranges. So observing the table, when x is nearing a value of 2, so when x is nearing a value of 2, this is 2, the value of f of x is equal to 3x plus 1 is actually nearing 7. So if you can observe, this value is actually nearing 7. In other words, 3x plus 1 approaches the number 7 as a limit when x approaches 2. We can say that the limit of 3x plus 1 as x approaches 2 is 7. So in notation, we can denote this one as the limit of, say, I will write it again, the limit of 3x plus 1 as x approaches 2 is equal to 7. So by definition, the limit of f of x as x approaches a is equal to L. And f of x is any function. A and L are any numbers, and L is actually the limit, and A is the number being approached by the variable x. Okay, so there are several theorems on limits. So we have here 8 theorems, and the limit of a constant c is actually equal to the constant, that constant. And the limit of a variable x as x approaches a is equal to a. And then we have here the limit of a constant, and the function is actually equal to the product of that constant, the limit, and the limit of that function. And we have here the limit of two functions is equals to the sum of the limits of that two function. Also, the limit of the product is equal to the limit of the limits of each function. So also with the quotients. So that is equals to the limit of the quotient of the limits of those two functions. If we have a rational function and we get its limit, then we just take the square root or nth root rather, and then get that limit of the given function. And then we have here another is the exponent. The limit of a function with the exponent is actually equal to the limit of that function raised to the exponent. Okay, so these are the 8 theorems in which we can use in solving for limits. So we have examples here. So we solve for the limits of the following functions. So we have the limit of x squared. Okay, we have the limit of x squared plus 4x plus 3 as x approaches 2 is equal to the limit of x squared plus the limit of 4x plus the limit of 3. And you can actually just directly substitute this one. So we have 2. Substitute the value of the number being approached, and we have 2. So substitute 2 to x, so we have 2 squared plus 4 times 2 plus 3, and thus we have 15 as the answer. Same as the above example, we have the limit of a quotient 4x squared plus 2 over x plus 4, so we just directly substitute this one, and we have an answer of 2. Okay. What if you have a transcendental function? So we have here a transcendental function which is the limit of the tangent of x plus sine x as x approaches pi over 4. So we just substitute pi over 4 to x, and thus we have tangent pi over 4 plus sine pi over 4. And so our answer will be a square root of 2 plus 1 over square root of 2 is equals to 1.7. So how do we get this? So you just get the value of the tangent pi over 4 and the value of the sine pi over 4. And if you're going to use your calculator, say you will be using, if you have pi, you can use rad to get this value.